I feel like I'm dead.
Lord Teaspoon, are we live? You've got to say hi. I know you're saying lurking.
Well, hello, folks. Can you hear us? What time is it? 7 p.m.
Lurking. Always lurking.
Teaspoon with us. This is excellent.
It
All
is.
right.
As long as we've got one.
Am I good to
yeah,
go?
that's always a good start. We love our crew. We do love our crew. So, James, what are we doing tonight? Other than saying hi to everyone.
Yes, well, welcome everyone. So welcome to the November alt.net. In fact, this is our last for the year, so enjoy it extra much because the next one is like the day after Christmas.
I've gone and got my Santa Claus hat or something and put that on.
Yeah, I haven't seen much Christmas stuff these days this year.
Well, that's because it's still November.
They usually wheel it out really early. But no,
that's straight after Easter.
Yeah, pretty much.
Hey, Mitt, how you doing?
Presents. So, but back on topic. So we're talking about Blazor. Aaron's going to talk about Blazor and where it's at with .NET 5. But first, actually, we'll add him into the stream right now because he's here with us.
Back. Oh, there he is.
We also have Andrew here.
We are live. Whoops.
We are live, yes. Welcome. And we have Andrew here who's going to tell us about...
And I'll be back.
All right. So Aaron will be back for the second talk. Andrew will go first. But we also have some other interesting things for you. We've got quite a lot of giveaways. So we were offered by Microsoft.
Why do we have the giveaways?
Are you answering that one, Richard? Is it rhetorical?
No, I'm just throwing it up there, seeing if you want to answer it. Just because Dimitri's confused, he thinks we're doing something with squirrels, apparently.
All right, you go ahead, Richard.
I've thrown you off your groove now. It's great. So if you didn't notice, for those who are lurking and saying hi, .NET 5 has launched. .NET Conf was on recently. Andrew, how did your talk go, by the way?
I think I've done all right. To my big surprise, I was pretty nervous. But I just, it's all right. It's in there. Go on. It's on YouTube. Have a watch if you missed it. Let me know. Maybe it's crap, but I kind of liked it.
You're really good at the sales thing there. I love it.
It is what it is.
I sold the JetBrains. Gee. .NET 5 launched, and so this is officially our .NET 5 launch party /event /everything else, which is great. And so thanks to Microsoft, we've got some giveaways at the end, which James is going to reveal later at the end, because I just said it at the end, right. As well as usual JetBrains giveaway.
Post also, so there's some.
Really? Did we give it away like that?
A little bit, yeah. But
what were we doing?
How many we've got or what you'll need to do for it.
Yes. I think it was involving public singing, right?
Yes, there'd be a lot of songs required.
Something like that, yeah.
No, stay to the end, but there's a lot of .NET 5 swag to give away and the usual JetBrains. Hang on, I think we've got Aaron wants to come back. Maybe. All right.
He's like a squirrel. In and out, maybe a clownfish, just a clown.
Here we go. So yes, we've got those and the usual JetBrains giveaway. So listen up for the questions for the JetBrains licenses and for the Microsoft swag. This will be a test of skill, typing skill, rather than listening carefully in the talk. But we'll talk about that more at the end. All right. Hopefully that set the right expectations. No, we didn't sell our soul to JetBrains. We sold it to ThoughtWorks for pizza and beer, and now we don't get any anymore. But now we've got Microsoft supporting us, so it's all good. All right. So should we go to the talks, do you think, Richard, or anything else?
I suppose we could. I mean, there's only so much chaos we can cause before we actually launch in and give genuine content and add a little filler at the start so people join. So we should do that.
All right, Andrew, you ready?
No, I don't feel like I'm ready, but I'm gonna give it a go anyway.
All right.
I wish I could prepare better for this talk. Maybe I should start with a joke or something. But you mentioned the Christmas is coming, and I saw today a nice picture, like it's a cave and Michael Bublé next to the cave, and the caption says like you can tell it's Christmas if Michael Bublé is coming out of its cave. I think it's a good one. I don't know if you like Michael Bublé or not, but my wife likes him. So Christmas is coming. Last meetup in 2020. Hopefully the next year will be better than this one. Today we're going to be talking about cancellation in JavaScript, and it's going to be a boring talk. I apologize in advance. Especially everyone. Many people here come with .NET C# background. Everyone is familiar with cancellation in .NET. So we might just as well skip the first part of this talk, but I'm going to give it a go anyway for the case, just to refresh your memory about that. Let's begin. So what is cancellation? A cancellation pattern is something that we use to stop a long-running asynchronous operation or synchronous operation. And .NET uses this unified model for cooperative cancellation, which simply means that there is something that requests cancellation and there is something that observes the request for cancellation. It's done cooperatively. Why unified model? Because there are many APIs that support cancellation, but just like there's many, like some API does it one way, another API does it totally different way. So .NET comes up with that unified model, which we can use to come up with a common pattern for all APIs that supports cancellation natively. So in .NET, it's done with lightweight object called cancellation token. And there is a parent object called cancellation token source. And I'm pretty sure everybody knows that nice and well. But we're going to be talking about JavaScript here. So in JavaScript, it's complete mess, unfortunately. And I don't know why. I recently just switched to JavaScript like on a large scale. And I miss a lot of APIs that we have in .NET in JavaScript userland. Despite many takes, an established cancellation framework is somehow still missing in JavaScript world. There was an attempt to standardize. It failed. The person who made it withdrew it. And then currently there is another proposal for cancellation. And luckily, that proposal is based on .NET model. So why is cancellation important? First of all, it's natural. Like in our real life, many processes can be interrupted in the middle of it by some external request, and pretty often we need some sort of clean up the mess because it was interrupted in the middle. It can be used for front-end workflows. It also can help with scalability of the backend because we have an option to stop something which we no longer need. It's no longer relevant. If it's a third-party microservice or something, we can even save a bit on billing by stopping it. So as well, proper cleanup and release of precious resources with try-catch finally, which is the C# language construct. JavaScript has it as well. Nice and convenient. And if cancellation is implemented properly, it is pervasive through all code layers, similar to async await itself. So it's like if you cancel at the top level, it just falls down like domino, kind of. Let's consider a simple example. Autocomplete. So we all know autocomplete. The user types a character. We start a delay because we don't want to call the web service right away, make it expensive. So when the delay is completed, then we do that REST fetch call or I don't know, gRPC, anything. Meanwhile, unfortunately, the user may have typed another character while we still haven't received anything from the backend. So ideally, at that moment, we should cancel the fetch, or if it was a delay, we should cancel the delay before we start the new sequence of these calls. And if the fetch is in progress and something is happening on backend, like we are calling a third-party microservice for like an autocomplete provider, we want to cancel that call as well to potentially avoid extra charges. And then we finally can start the new sequence, like another delay, another fetch for the newly entered text, and so on. All right, that's nice. So what do we have in .NET? Now then, again, we have the cancellation token source. This is the producer side of the API. That's actually something that triggers the cancellation. It's normally external to the asynchronous operation itself. Because something cancels us, but we don't do it ourselves. And the cancellation is requested through cancellation token source cancel method. Now the token is a consumer part of that API, and the token is used to observe external cancellation. And the third part is the exception itself, operation cancel exception, which we get if something gets canceled. We bail out of all nested levels of our calls. And when we have catch for exceptions, we can differentiate it was actually cancellation and do something, or don't do anything. We can just swallow it. I think cancellations are safe to swallow. All right. How do we observe the cancellation? So the cancellation token has that method register. And it's basically, you pass a callback. That callback will be called at some point where the cancellation is actually requested through the source. In C# and in .NET, we have added complexity of multi-threading. It can happen technically on any thread unless you request it to happen on current synchronization context. It's pretty hectic. Fortunately, in JavaScript, we don't have that. It's just a single thread. It's a blessing. And you can think of cancellation token register as like register an event handler for hypothetical cancel event. And back to our autocomplete example, that's where we may want to call clear timer for the delay and reject that delay promise. Or if it fetch is in progress, then we want to call abort controller to actually abort that call. And that would reject the fetch promise. And also, if you do something synchronously, which in JavaScript really shouldn't be doing, or like on tight asynchronous loops when we yield, but it's still kind of tight. I'll show that later in the demo. We may want to call cancellation token throw a cancellation requested. That's kind of polling for the status of cancellation request. And this thing is, it actually throws an exception. So we need to get ready for that too. Moving on, what's nice about the .NET model is that it can cancel a whole hierarchy of asynchronous operations. So it can be a tree or like even a graph of different workflows. And as I'm talking about workflows, it's for the context of this talk, it's just like a sync method that does a bunch of asynchronous calls and awaits some of them, or maybe doesn't await, like fire and forget some else. But in like on a large scale, it can be more than that. Like there is a startup, I think it's called Temporal IO. They represent the whole business logic as workflows. Like for example, sign up for subscription, be in a client, and then canceling subscription is their workflow. And they actually trying to represent it also like a bunch of asynchronous sub workflows. Don't mean to confuse anyone. I hope it makes sense. The workflow here is just a sync method. Let's move on. So cancellation token source create link token source allows us to maintain a tree or graph of different levels, hierarchy of cancellations. And for example, we might want to create a new link token source and pass that token to a child workflow which we're about to start as later in the demo. And then when we want to cancel that chart workflow, we just request cancellation on this token that we created. It will be internal to our parent workflow, but not, the parent workflow will still remain operative. And then if the whole thing is requested to be stopped externally through the token that is parent to our link token, it will just happen automatically. So it just propagates through the whole tree. We don't need to do anything specific for that. That's nice. So that's C# and .NET, all good. We all know that. What's up in the land of JavaScript these days? So as I mentioned before, there was a proposal. It was canceled. There is another proposal which is based on .NET model, which is really nice, but it's at stage 1. It's very early, and things can be very slow in JavaScript land. There is a TC39 committee. It can go for years, or it can take a couple of months. We never know. So there is a nice article I came across by Ben Lesh, who I think is the leader for reactive extensions for JavaScript. And so you can find the link in my slides. I'll publish that in my GitHub repo as well. So Ben offers to use Bluebird library for its cancellation support, or use another promise as a token. Just we can raise 2 promises, our API or cancellation promise, whichever wins the race, then we go on with that one. Use reactive subscriptions. It's really cool. Myself, for some reason, I'm not a fan of reactive extensions. I use them, but just like on a little scale, when I need to combine a stream of events, filter it, and then do something with that stream of events, I would rather be using the language constructs, like for await loop, to process asynchronous streams. But still, reactive extensions is a super cool and powerful technology. So if you are fluent with it, maybe just stick with it. And one last option, just ditch promises and just use observables. You can go to that article and read more. It's a nice one, but why just don't use what we have in .NET? We want that in JavaScript. And yeah, there's one more. Like lately, abort controller and abort signal and abort error is being increasingly adopted by Node.js, and some browsers support it. Pretty much all evergreen browsers support it for the fetch API. So it's very similar to .NET model, but the thing is, it doesn't support hierarchy, it doesn't support polling. So we can kind of implement .NET model with abort controller, but it's a lot of work. So I've been looking for a library that does the .NET model already for me, and you just go to npm and js.com and search for cancellation token source, and I found one, and it's called Prex, or Promises Extensions for JavaScript. And it turned out the author of this library is a guy called, his name is Ron Buckton. He is a senior software development engineer for TypeScript. He's a member of TC32, who's basically doing the whole thing in JavaScript land. And he is actually the author of the current proposal for ECMAScript cancellation. So it must be good, and it actually is good. It's got good test coverage, and it provides everything that we have in .NET, just with slightly different names, but very close. So there is a deferred for task completion source. There is semaphore for semaphore slim. There is a sync queue for .NET channel. There is delay for delay, and of course, there is cancellation token source, cancellation token, cancel error for operation canceled exception. So it's ready. We just need to use it, and we can use it, the same unified model, for canceling different styles of APIs. Again, abort controller for fetch, clear timeout we can call for set timeout, cancel animation frame for a request animation frame, etc. On Node, at Node.js side, at the backend, We can call stream end, stream destroy, which also bails out the API and ends it prematurely. And also, which is very important these days, we can cancel gRPC calls. Right, I have not so much time, so I better move to the demo. Oh, yeah, like typical code pattern for cancellation. Like we wanna adopt the abort controller. So we have token to the fetch URL. What we do here, we just register our callback on that token that actually calls abort controller abort. And then we await the result of the API, of the fetch. We pass abort signal, which we acquired here from the abort controller. And luckily, it just happens. So when this thing, if it fails with exception native to fetch, we'll just get that out of the function call. If it fails because we excuse me, that's the next slide. This one just will fail because when the token is signaled, we call abort controller abort. That will fail the fetch API, and basically, in case if it hasn't failed, this one will fail it for sure. So that's a pattern how we wrap any native API. What if there is an API that can't be canceled, but we still want to cancel it? In this case, we kind of become disinterested in this. So we use promise any. We create a promise. I use deferred for this, which is task completion source and .NET. We register our callback on the token to a signal that deferred. We resolve it, and then where we actually call the API here, we use promise any, and it will fail if the API failed, or it will settle successfully if our token is signaled, in which case we will fail it with cancel error. So I hope it makes sense. Sorry for rambling. Moving on to the demo. I initially wanted to do something more complex that I've come up with. I wanted to make a chat application, which is like WebSocket based, front end in plain JavaScript and back end in Node.js. For time constraints, I ended up just with front end. But here, what we have, so we have a very basic application that I click start button and it starts tracking the mouse cursor. Every single circle that you see here is an individual workflow. And I try to express that model in as an asynchronous method. So I stop and I start. When I stop, I request cancellation. Again, all circles disappear. Let's have a look at the code. Let's have a look at the code. So that's the run method, and it's kind of, because it's asynchronous, it's pseudo-linear. So what I do here, I try to, like in real life, simulate the set of events, but when I wait for each event, it's still a linear workflow. So first we wait for document content load, so the document is ready. Then we prepare our start button, and it's a mess because I don't use any frameworks. It's plain JavaScript without any MVVM or I don't know, React. But this one is very easy to adapt for MVVM, which I grew up with. For simplicity, it's just very plain JavaScript. UI is mixed up with the logic here. So we have that while loop. In that while loop, we await for click event in this one. When the click event happens, we check the current state. If the tracking is active, if it's non-active, we start the tracking. And when we start the tracking, I have that track mouse async method, which is actually drawing those circles. And it's like fire and forget. I don't actually await it here. I simply run and forget about it. Besides one thing, I pass the cancellation token to it here. And then I continue looping. Next time the button is clicked, well, the state is now active, so I need to stop it. So I signal cancellation here on our token, on our cancellation token source. And the token is passed to this track mouse async API. Don't have much time to go in the details into what is going on inside the track mouse async. But briefly, all it does, I have a stream of mouse events. For each event, I call draw mouse track here, which draws little circles. And so I have a bunch of them because, again, it's like a fire and forget here. But I do pass the token. So when I click the button on the screen again, they all get canceled, as many as I have on the screen. That's how hierarchical cancellation works. Now, next demo would be let's say I want to cancel the whole run thing. So remember that run method where we wait for click event in the loop and change the state from active to non-active and cancel all those circles. Now I want to cancel the whole thing, like what you see on the screen. So I have, whenever I launch that run method, I now create another cancellation token source. And I cancel it just in 10 seconds. So just in 10 seconds, the show is over. And I pass now this token to the run method. So I have the source here. I pass the token to the run method. And going back to the run method, I now create here, whenever I need to pass the cancellation token to our track mouse async method, I now create a linked source. So the outer token, which was provided me by something that called that run method, gave me a token. Now I use the token to create a child linked token, and I pass that to our mouse drawing, to our mouse tracking procedure. Let's have a quick run. And by the way, I'm using Snowpack here. It's a very nice tool. You should give it a try. It's pretty new, but it's very cool. And the prax itself, I actually had to use Browserify because it's more like node-oriented. That's the only way I could use it in the browser, but it's not too bad. It's just like, I think it's like 80 kilobytes or something. Okay, so let's start it. So it's pretty much the same, but hopefully, like I can do whatever I want. I can, again, start, I can stop, and this is our workflow. And now it just stopped. The show is over because of that timeout of 10 seconds. That's how I can cancel. It's very easy to adopt existing workflow to be canceled externally. And finally, I hope it all makes sense so far. Sorry for ranting, but let's do something more interesting. So let's, when we draw those circles in, when we track the mouse movement and we draw those circles, let's now also show the current coordinates of the mouse. So it was very simple previously, but now we want to draw the current coordinates. And that's another workflow which concurrent to our mouse tracking. Let's do a quick run. Let's build it first. So we now show the coordinates. And to make it sweet, if I don't move the mouse, they start rotating. And when the circles are gone, and the most recent circle is gone, the coordinates are also gone. So it just, this sample is very basic, but in real life, I actually use it for a conversational voice API. And it's also like, instead of mouse movement, there is some voice input from the user, and it's happening at the back end, but it doesn't change anything. It's still a workflow, which consists of many child workflows. Each child workflow can start its own child workflow, and it's a tree, can be graph, and it all can be canceled interactively, or let's see, I think it will still cancel it because of the timeout of 10 seconds. Yeah, there you go. That's pretty much it. I'm running out of time, but I could go for more, a lot more to cover, but not in 30 minutes. This code is available in my GitHub repo. Let's go back to the slides real quick. Yeah, so the final point is, if you already use and love cancellation pattern in .NET C#, bring it on for your JavaScript and TypeScript userland and enjoy it. I have a little reference section as well that I used when I worked on this talk. And I think I'm happy to answer any questions. I knew you would do that. I actually want to apologize because I actually didn't even rehearse this talk. I didn't have time for that. I'm sorry for ranting.
Don't apologize. We wouldn't know. Questions for Andrew, anyone?
I think there are no questions because it was so confusing. I'll polish it for the next time.
Yeah, everyone's just like absorbing this game. What did we just see? So that was with Plex you were using in
Plex,
the.
Yeah, let's click it.
The library.
And that's that library. So it has all those goodies like that I use in .NET a lot, and it just suddenly they are not in JavaScript, but thanks to this library, they are in there. And the good thing is, I think that whatever they come up with, that proposal for cancellation in JavaScript, it will be very closely based on this library. And there's one more thing. So people will probably use reactive extensions for what I've just shown. I'm just not a fan.
That's cool. And the only question we got was, did the applause finish naturally or was it cancelled using a token?
What about the one about single thread? What about this one? Single thread.
Oh, that's a good question, actually. It's really good because people think that, wow, it's single-threaded environment. We're not going to go all those issues with deadlocks and concurrency, but that's not the case. Because especially if the code is heavily using async await, you can end up in a situation where just you have reentrancy. Like that's, if I go real quick to that mouse drawing thing, I actually have a semaphore there, only because when you cancel something, you only request cancellation, but you are not sure when the cancellation will be actually like implemented and finalized. You can only request it, and you can only hope it will be quick, but how quick can be on the next iteration of event loop, can be in a couple hundred milliseconds, we don't know. So before we start something new, like the next iteration of the same workflow, it's a good idea to guard it with those like a semaphore, and that's what I do here. And That's why we need semaphores, etc., even in a single-threaded environment. When we deal with concurrency, and we need synchronizing primitives. Hope it answers the question.
That sounds like it. Yeah, Lord Teaspoon weighed in, but I think you've given a more comprehensive answer there. All right, sounds good. Any other questions for Andrew? Right.
Doesn't look like it at the moment.
All right.
I promise I polish this talk for the next time I ever give it anyway.
It's pretty smooth, Andrew, actually. It's good.
Well,
so for the next .NET Conf coming up.
JS Conf, maybe? I don't know.
Yeah.
TypeScript Conf.
All right.
Thanks for listening. Thanks for watching.
Yeah, thank you very much. Well, it's good to have you on the show and give us some hardcore technical content.
Shall we kick really seamlessly across to Aaron, or should we make it really awkward and
let's try the seamless
kind of pause and rumble?
Here we go.
Aaron. Yeah, nice.
We don't know whether you're joking, Aaron. We can't hear you.
No, we prefer it that way.
Yeah, I was trying to make it nice and smooth and seamless as possible for you all. Yeah, like you've done a good setup, so I thought I'd continue on the positive momentum that you were tracking with. Anyway, well, thank you everyone for having me back at alt.net, and tonight we are going to be talking about modern Blazor applications. For those of you who have not met me at a previous in-person or virtual alt.net event, my name is Aaron Powell. I'm a cloud advocate at Microsoft. I've been doing web development for 15 years or so and have had a chance to use pretty much every web framework under the sun, all the way back through to like classic ASP and .NET and JavaScript frameworks and everything sort of in between that. If you want to catch me on social media or anything like that, that's the various locations that you'll find me. And if you've got any questions following this talk, feel free to ping me on there if you don't want to ask the questions now. Boring. Oh, okay. The audience is obviously saying that that's enough of listening about me. You're actually here to learn about Blazor. So just to make sure that we're all on the same page, I want to kick off with what is Blazor? For those of you that might not have had a chance to play with it or have looked at it in much detail or have even heard of it. So Blazor exists in two forms in the .NET framework. It's an approach to doing web applications and have a modern web application experience, that very dynamic in-browser experience, but without having to write JavaScript. As I said, there's two forms of that. We've got Blazor Server and Blazor WebAssembly. I'm predominantly going to talk about Blazor WebAssembly for the rest of this talk, but just to cover off all bases, Blazor Server is, it runs on a server, kind of like a normal ASP.NET application would, except everything you experience from the client side is still written in C# or F# and Razor files for like the HTML. So if you need to bind to an event, it's still written as C#. But what happens is that when you interact with that event, like you perform some action that needs to update the DOM, a message is sent over a WebSocket to the server, it does the processing, and then it will send back the changes. This, I guess, is kind of like an update panel, to use a analogy that will annoy a lot of people, but it's nowhere near as overly bloated as the update panel was in ASP.NET Web Forms. Now, Blazor WebAssembly is the other end of the spectrum, where it doesn't require any server because you actually compile the whole .NET application to WebAssembly. This means that you can just serve out HTML, CSS, tiny little bit of JavaScript bootstrapping, and then .NET DLLs that are running in the browser on the WebAssembly runtime. So like you literally compile the entire .NET framework down. So this was on the Mono framework, but when they merged Mono, or at least parts of Mono, into .NET 5, that meant that they actually now run the .NET framework properly in the browser. But that means that you can build an application realistically without writing any JavaScript yourself that experiences the same way as you might have like a React or a Vue application. It just so happens that it runs in WebAssembly. But let's jump over and do a quick demo just to have a look around at what it is for those of you who haven't seen it yet. So we'll start off by creating a new project. And we will use the Blazor application here. And I've realized I forgot to increase the font size in Visual Studio, so we'll have to do that shortly. But you can see here we've got Blazor Server, Blazor WebAssembly. So we hit create on the WebAssembly one. Give that a moment to spin everything up and hope that my Visual Studio is not going to lock. Oh, look, it's locked up. It's not responding. Isn't that a good start to the demos? No! Okay, let's come into
your soundboard.
Oh yeah, I've got the soundboard going. I knew I had to, get used to trying to use it, and there's nothing like some demo files to throw in a few things here and there. Let's just pop font size to, we'll go 30, so it's nice and big. Boom. No, I don't need to install any updates. All right, so this is the Blazor WebAssembly application. We have it's actually almost a console application. So we have a program.cs, we have a main function that takes some arguments, and inside of this we create a WebAssembly host. We specify where in the DOM that the application is going to be rendered into. We can inject things into the dependency injection framework. It's an IOC container that's running in there. So you get full IOC, like all the things you want from doing .NET development. This one is just got a service, which is a HTTP client. But if you had another one that was representing the way that you're doing like fetch requests or something like that, you could bind that service here and then just inject like an interface, so you can mock it out easily. We then have pages. These pages are like a counter page here, which is a HTML button and a couple other bits of HTML that are going to render out on the screen as HTML. But what makes this difference to like writing just a normal web application with normal web technologies is this on-click is then bound to a code function that you see on line 12 below us, using the @ binding of onClicked to increment count, and then this is C#. So this is a C# code block that lives within inside of this Razor file that can do stuff. Now, you can pull these out and put them into separate files if you don't want to have inline code. That's entirely up to you. We can also do even more advanced things like do conditional tests and then load different bits of HTML, do network requests using the HTTP client that we would be familiar with doing any other sort of .NET application programming, create classes, get all that value that we can have out of doing a .NET application. So we'll just fire this up. This is going to run just on a dev server running in iOS Express. I'm obviously using full Visual Studio here, but you could do this in VS Code just as easily, and it works fine on Linux or Windows because it's all on .NET 5 or .NET Core 3.1. So that was when Blazor WebAssembly was first made, but generally available. Okay. We'll just do font sizing on a few different things around the traps so we can see everything. It's HTML. If I look in here, we've got divs and elements like that. If we have a look at the source, we have some JavaScript here. We also have a WebAssembly binary, which is the .NET framework as it's running. Come over to the counter. I can click it, and like we're not seeing like page refreshes. We're not like this. It's just running .NET in the browser. Same if I do hit that fetch data, we'll see that that's done a network request to pull down some JSON, which has then been strongly typed, iterated over an output. So and again, this is happening all in C# code that's been written, but then running in the browser as though it was just a JavaScript application or like a static web application. But we're not here to just learn about the basics of Blazor and stuff like that. There's been plenty of talks, and I know there's been other talks at Alt.NET in the past that talk about Blazor and getting started and things like that. I wanted to focus on what's new with Blazor in .NET 5. Because .NET 5, which came out a couple of weeks ago at .NET Conf, or it became GA a couple of weeks ago at .NET Conf, had a heap of new features in it. And a bunch of new features were for Blazor applications, specifically Blazor WebAssembly applications. I'm not going to have a chance to cover off everything, so I picked out about 4 or 5 things that I think are really cool and make it a lot easier to build Blazor applications using .NET 5. The first is CSS isolation. So if you've done JavaScript development using modern frameworks like React and Vue and Angular and stuff like that, there's a common pattern that people use called CSS in JavaScript. This is where you actually write the CSS that your your code is going to need, your HTML that's going to get rendered out needs, but you write that in the JavaScript or as close to the component that needs them. And then you run a preprocessor over the code base to generate the CSS, but you generate specific CSS for the usage of those components. What this means is that you can avoid the cascading nature of CSS. Anyone who's done enough CSS will know that trying to write a really complex, large DOM-based application that relies on CSS, you're going to invariably put something on a selector somewhere, and it's going to have an inverse effect on some other elements somewhere else in the DOM. You're like, oh, how did that happen? Like how do I fix that? And then you're just like whack important everywhere, and you're getting more specific on selectors and hoping that things are just going to hold together for that page. And then you go to the next page and you find that you got to start up the process all over again. Now, with CSS isolation in Blazor, what we can do is we can create CSS that is tied to specific Blazor components. So we take the way that it works is we create a file that is named the same as our component file, so like index.razor.cs, and that is then where we would put the CSS that we want, and then that is isolated for just that page or just that component wherever it's used. Back over to our demos, and I'm going to come over to another application that I've got here. And I'm going to assume that the stuff is it's like the font size is actually reflected across all my instances of Visual Studio. We'll find out in a moment. But let's start this one up. This is a slightly more complex application. It's sort of like a notebooks application where I can like write a bit of C# and execute that and so on and so forth. But it does what it needed to do, but it doesn't look particularly pretty. You click on this button, I can see stuff, and it works, but we want to make it look a bit better. Like that button, it's like so old school. Like it's got square corners. Like who does square corners on buttons these days? Really, it's so amateur. So let's do that, but I only want to target that button, and that is where CSS isolation can come in. Now, I already actually have a CSS isolation file created. You'll see that's nested under the index.razor file in my Explorer over here. And if I open it up, it does have the correct font size, excellent, and it has a bit of CSS in here, which is already targeting the isolation. If we open up the Razor file just to see what it looks like, I just want to target this button. Now, there's no other buttons here, so I can just go, well, I just want to target buttons. So let's chuck in some new code. Drag and drop something out of my toolbox, which of course has lost all my snippets. Fantastic. I like it when demos are going really well. That's good. We can just go git checkout 02 and we'll jump through. And look at that, the magic of editing. We have brought in some code. I'm just styling that button now specifically. Let's start up our application again. Give it a moment and we'll see a whole lot prettier a button. Let's bring up the DevTools on the side so we can have a look at that. A little bit too far, I think. Okay, so there's our button. Excellent, but it hasn't touched these buttons in the header. Excellent. That's what we wanted, and that's because we used CSS isolation. So I can, if we inspect this element in the DOM, you'll see that what it's done is that button now has an attribute b-b w4m, etc., etc. And then if we have a look in the CSS panel at the bottom, let's just move that up a touch, we'll see that there is a selector button, but it now has that attribute attached to it. So what it's done is it's taken the CSS that I wrote, looked at the components that need to be output, and has gone, well, I'm going to generate, I'm assuming that doesn't look like a SHA. I mean, it's possibly like some kind of a hash of it, and gone, well, like let's just generate some kind of a unique identifier for that. It means that only that button is getting targeted, because if we have a look at these buttons up the top, they have a different attribute on them, so they don't get affected. Excellent. So that means that we can now easily create CSS that is going to be just isolated and targeted for parts of our application, not across the entire thing. The next one is JavaScript isolation. So this is like a similar idea with CSS. Like we might want to write some JavaScript for our Blazor application that, well, we don't necessarily want that exposed everywhere. Now, I understand that the whole point of Blazor is that you don't have to write JavaScript, but there are going to be times that you may need to break into JavaScript land because there's just something that's not available in Blazor. Now, this could be because you're creating a third-party library, like wrapping around like a Google Maps API or some other API that you want people to be able to interact with from Blazor, but you're going to have to write the JavaScript interrupt code. Now, the approach to doing that, like you've always been able to do that with Blazor, right? Like pull JavaScript from C# and vice versa, but you had to create these functions that were going to be global functions. So you were potentially having a conflict with any other JavaScript that was loaded on the page. If you happen to choose the same global function name as someone else, it's not great. You would end up with only one of those functions actually getting registered. But with Blazor in .NET 5, we now support the ability to use ES modules, so JavaScript module syntax, to import and or to export things specifically from files, and then import only the things that we actually require. Let's go over and have a look at how that works. Because that my toolbox is playing up, we'll just jump straight through to the pre-written demo. Now, something that, as I've been playing around with this, it works a little bit different to the way that the CSS isolation works. Is you don't have a file that's nested under your component. It's not intrinsically confined to your component. It's just it's more about importing parts of a JavaScript file rather than just having JavaScript that's always imported and always available everywhere. So I've created a little snippet of JavaScript that is going to look at the network connectivity of my browser and then just report up my network information. So this will tell me like what's the speed of the connection that I'm on, what connection type does the browser think that it's running in, and a few things like that. Now we have this send info function here at the top, which is going to send it back up to our .NET application. You see it's doing .NET invoke method async. So that's how we call back to .NET from JavaScript. But I don't want that code available to anyone. I don't want anyone to be able to call it. I only want it to be called when the change event is happening from my navigator.connection. So I'm just exporting a function called monitor network, which allows me to set up this monitoring tool. Inside of my index.razor file, I'm injecting the JavaScript runtime using add-inject, which is how we inject a dependency into a Razor file. IJS runtime is the way that we do interop with the JavaScript runtime that Blazor is operating in. And then we'll come down a little bit further, and I've created, I've got a record type called network information, which just represents the data coming back from JavaScript. We have an action that'll get called when it comes back. But the important thing is, let's just collapse the Explorer for the moment, is that we're using the JavaScript runtime. We're saying invoke async. So this is going to invoke some code in JavaScript. And we're saying import the path to that JavaScript file. So it's going to be /index.js because that's where it lives. This is going to give me an IJS object reference, which is my JavaScript module. And then from there, I can invoke functions that have been exported by that module. So I can invoke the monitor network function, for example. Let's start up the application again, have a look how that runs, and hope that everything is still working. Pop our DevTools open, and okay, so I'm currently on a 4G connection because Australian internet reports itself as 4G. That's how fast my browser actually reports itself as. In the DevTools though, I can come in here and go, let's go slow 3G, and then that reports as now a 2G connection. Fast 3G, it's reporting as a 3G connection. If we go offline, interestingly enough, it reports as a 4G connection. I'm not quite sure what they're actually meant to represent. But so this is obviously just a synthetic example that I've got for the point of this talk of showing how you can do that interop. But this is like you could imagine that someone has made a library that they want to make available the information from the browser, but you can't do that natively in Blazor at the moment. So we use a bit of JavaScript and we don't expose things we don't need exposed just globally in the JavaScript space. Okay, back to our slides. Okay, the next thing I think is actually really kind of fun. If you're building applications that are, or you're building libraries that you want to use in Blazor applications and you want to use in maybe a mobile application or like just a normal ASP.NET application or things like that, is the browser compatibility analyzer. So if you've got something that is like something that you want to have available from your library, but maybe the browser doesn't support that. Like maybe the way logging works, it can't be run in the browser, or there's some other functionality that you can't do in the browser. It was actually kind of difficult to determine whether or not that existed using Blazor prior to .NET 5. Basically, what would happen is you would hit that function and it would just throw a not supported exception because the browser didn't support doing that. Now we have an attribute that you can attribute onto types, members, assemblies, that basically says where this thing is available from. And then at a compile time, it will be able to detect and go, oh, hang on a sec, you've tried to use some functionality that has been marked as not available with inside of the browser. So, okay, it just kind of like simplifies the ability to do things, not rely on runtime failures, rely on compile time checks for you. Then we've got input file. So while Blazor, you could always write out HTML inputs and have them do the things they need to do and like interact with them and stuff like that. Working with files was a little bit tricky, just because of the way the file input works in the browser. It's a lot more. It's not more nuanced than just like a text input or a text area or radio buttons and things like that. So what the Blazor team has done is they've made it a whole lot easier to actually get access to that file. Okay, we're going to jump to another branch and we will start up our application again while we navigate through and find the right bit of code. I'll pop that to the side and then this one over here. Yep, that goes there. Now, if I come into this file cell, there we go, expand that up fully. So this has got an input file. So that's the component that we can see there. The purple denotes that it's a Blazor component as opposed to the like just a regular DOM element. And you'll see that it has an onChanged event that's going to then fire this function that's just down below. Let's just have a look at this in action before we dive straight through to that code. So we'll come in here and we're going to full screen that, and that hasn't redrawn properly, but that's okay. So this here is a scratchpad where I could like write out C# code and then execute it. Kind of like think of it as a really basic version of like a Juniper notebook, something like that. So let's make some code that's then going to like process some data. So we're going to pull in from the CSV parser library, and then we'll do var contents equals system.encoding, system.text.encoding.default.get string, and then well, we were going to need access to a file that's getting uploaded. So I can do that. I can go choose file, pop that there, and then we'll say file 1. So that's actually available with inside of my application based off of the name that's here. So now that's, I could actually use that. Obviously, I'm just typing it out here, but I could use that also in the Blazor side of it. And then we're going to do var const. I'm used to writing JavaScript as well. With raw data will be CSV parser.csv parser delimiter of comma, and then we'll do parse the contents of the file and then to array that, and then we'll just do raw data and we'll just dump that out. Let's see if I wrote all that correctly. Should execute and we should get some output. No, that's because I forgot to new that up. Excellent. Cool, so that's worked, but how did that work? Well, this handle file chosen async is the thing that got called when I uploaded that file, or when I selected that file. I mean, I didn't technically upload it because I never needed to send it to the server, but this gives me an input file changed event args, and inside of that I can access the file, and from that file I can open a read stream, which I can then get the contents of. So you could imagine that, like, I'm obviously pulling some data here and then like manipulating it in my application, but let's say that you are doing some sort of image manipulation. So you would upload the image, you could actually render that to a canvas so someone could interact with it without ever having to do server round trips. You could do data processing in the browser without having to do server round trips, which I think is really kind of cool. But yeah, this is then just output like a whole bunch of data rows. In fact, it's put a lot of data rows out, a lot of data. And that brings me on to the next thing I want to talk about, which is component virtualization. Again, if you've done stuff with JavaScript frameworks, particularly React, React popularized this a couple of years ago. The idea of, well, if you've got to render out like 1,000 rows in a table, it's really difficult for the browser to do because there's a lot of DOM elements that it's got to manage. And it takes, like, the more DOM elements you've got, just the slower the browser is because it's the more stuff it's got to manage. So instead, you kind of trick the browser and tell, well, no, there is a lot to render, but, well, we're only going to give you a subset of that. So let's have a look at the DOM here. Let's just inspect that and we'll collapse that down. So this table here only has this TR and then has what about, let's collapse, sorry, the TR. And then we only have dozen or so table rows inside of this table, but then we have kind of like a top and tail div, and this bottom div is huge, whereas the top one's small. If we start scrolling down, you'll notice that the TRs are changing. We're not getting more or less of them, but the reason they highlight is because something's changing about them. And the height of the top and bottom div is actually changing as well. So it's telling the browser, well, no, it's actually a whole lot taller than you think it is, and that's causing the scroll bar to appear. So this is virtualizing that table so that we're not rendering out, potentially thousands of rows. And this is happening in, if we come into, have a look at how this works, we just wrap a virtualize component, we give it a data source, and then the context is what do you want to call each item of that data source? So it's running as a for loop. It's going to call entry in this case, but you don't have to. You can just refer to it as context if you don't provide a context itself. If the context is an array, then it's going to do the TR. Otherwise, it'll iterate over all of them and put out all the cells. Cool. And then you can control how many that you want to render at any given time, but it'll virtualize the content that's available there. And it does have your tables, it could be divs, it could be list items, whatever you need it to be. Now, there's a heap of other things that came out in Blazor for .NET 5. Performance improvements, reducing the amount of size that you've got in the WebAssembly binaries that are getting shipped to the browser, just so it's faster, more input types, support for doing custom CSS classes for validation. So if you're using the .NET validation framework and you want to combine that with your own CSS UI framework, like whether you're using Tailwind or Bootstrap or name whatever one you want, you can control what the class names that are going to be generated by validation errors so that they match the ones that are expected by your CSS framework. And heaps of other stuff that's available here. But we've talked about how we can do dev with Blazor, but there's still one thing that we're kind of missing. Well, we're building a Blazor application, but how are we going to interact, connect that up with some sort of a backend? We're going to need to probably do some sort of server interactions at some point. We want to get data, right? It's going to be a very static application if it never talks to a server to get any sort of data, which is fine. It's probably okay for a blog, but maybe not for an e-com application. So you've decided that you're going to go with Azure Functions as your backend. Now let's go full serverless because we can do Blazor WebAssembly. We don't have to deploy it onto a server per se. We can run that on as a static site host. Well, we can do then a serverless backend in Azure Functions. It gives us HTTP triggers, so that it's going to give us access to data. It gives us auto binding through to Cosmos DB or to queues and storage accounts, whatever we might need. But we're probably going to want to do some proper CI/CD for this. So maybe we'll want some GitHub Actions so that we can easily every push will build, deploy. Maybe if we can push a pull request branch that's going to be deployed in a staging environment, so we can check that and how that works. But I keep saying one thing that's kind of critical there is deploy. Where are we going to deploy that? Or we can deploy it to an app service, but then we're running kind of on a .NET host or an Nginx host or something like that. It kind of defeats the purpose. App service is designed, what would be the point of having functions then? We may as well have just written it entirely as an ASP.NET application. Well, maybe we could do storage account, static hosting, but then we've still got to work out how we deploy our functions. That's going to be separate. And then we're going to do our own SSL management. We're going to have to put a CDN in front of it. We're going to need to do something so that we can support custom domains. That's probably happening in our CDN. And what about fallback routing? How are we dealing with all that kind of stuff? There's a whole bunch of different ways we could do this in Azure, but none of them seem to fit quite right until we start looking at Azure Static Web Apps. So Azure Static Web Apps is a service that we've got in preview at the moment. We launched it at Build earlier this year, and at Ignite, we added support for doing .NET hosts. So originally it was just JavaScript backends with JavaScript frontends. Now we support .NET backends, so .NET Azure Functions, whether they're C# or F#, probably VB.NET. I've never tried, but I'm sure that could maybe work. Maybe. And then Blazor as a front end. So if you want to do like full .NET end-to-end as a fully serverless application, we do that with static web applications. It does custom domains and SSL, manages the SSL certificates for you. In fact, I don't think you can even turn off HTTPS on static web apps, which is good because you shouldn't. It also provides integration with GitHub Actions, and by default, it will automatically provision a GitHub Actions CI/CD pipeline for you. So you kind of are forced down that route anyways. No right-click publish straight from Visual Studio or VS Code. It also has things like built-in authentication. So whether you're using Azure AD or GitHub or other social media providers, that's provided just out of the box. You don't have to do anything for that. Now, I think I'm probably running out of time, so I won't have a chance to do a demo of this today. You can watch my .NET Conf talk where I actually do a demo of some of this stuff. But in the essence of time, I'll just throw up the final slides, which actually has some links out if you want to play around with some more of this stuff yourself. So Static Web Apps supports both Blazor WebAssembly 3.1 and 5, but the Azure Functions currently only supports .NET Core 3.1, whatever the LTS is. It doesn't support .NET 5 yet. I'm sure that will be coming in some point in the future. I'm also working as a workshop for doing Blazor WebAssembly applications that I'm currently porting across to run in a full serverless model. So stay tuned. I'll have some information about that probably in the new year. And there's some docs links and QR codes for anyone that wants to learn a bit more about Blazor, deploying static applications, and things like that. But like I said, in the essence of time, I'll wrap it up there. Thanks everyone for having me. My name is Aaron Powell. If you want to find me online, these are the places that you will find me.
Sweet. Oh, there it goes. There it goes.
Gotta finish.
So there's a few questions that come through. James, we might just need to switch Aaron's head around so it's not at the bottom because the questions all overlain.
Yeah, because I can't jump above the box.
Oh, there we go.
See,
look at that. Did you see that happen? That was smooth. Obviously, some of the things, Aaron, just to start off with, file sizes in terms of what gets downloaded to the browser. Did you want to do a refresh of your demo and just have a look at what comes through?
No, because I have some optimizations running so that it's actually not. It's got everything super aggressively cached. Let's see if I can force it to download all the WebAssembly stuff. Where are you? Let's see. Yes, disable cache.
Just Control F5.
Yeah, but no, it's not wanting to do that. I think. Yeah. Here we go. No, it's not that. It's caching it somewhere, and I can't remember exactly where it was. I found it. Long story short, you're looking at megabytes worth of download, not kilobytes. So that's one of the things that the team is very conscious of and is very much working towards is reducing file size. If you're concerned about the file size, Blazor is a lot better suited at this point in time for internal applications or applications where file size is not a major concern. If you're able to leverage things like service workers and do offline caching of the files so that you don't have to fetch them every single time, I go down that route. Because that will get you, you might have an initial hit for a user where it's going to result in a large payload download. but they will get performance benefits going forward because you won't actually have all of that payload downloaded every single time. Actually, let me try this in a private mode browser. And let's see. It's too quick. No. I will endeavor to find out. Actually, here we go. One last attempt. There we go. Okay, so here we go. Now you can see it. Now remember, this is running in debug mode, not in release mode, so it hasn't done any like compile time optimizations. But this was 23 megabytes of downloaded. But you'll also see there is a lot of downloads. If we hit XHR in particular, you'll see these are all the DLLs that were downloaded. So we've got authorization, configuration. I saw system.link was in there. Yep, here's link and all that kind of stuff. Now, because we're not doing any kind of compile time optimization in debug mode, yeah, it's going to be a whole lot bigger. Release mode will reduce that a bit because it can do some smarts around it. And I know they're looking at things like ahead of time compilation so that you can try and determine what things you actually need. And like if you're never using anything link related, then it won't include the link assemblies, for example. Yeah.
So things like app trimming and method trimming, is that?
Yeah, like that's the kind of stuff that I know the team, like it's one of the biggest things for the team because yeah, it's a constant bane of the fact that yeah, you're downloading 20 meg worth of assemblies and you really don't need most of those. Well, at least there's probably a lot of them that you don't need, particularly for a simple application like I had there.
Yeah, Linkonius says release mode can bring it down to about 2 meg apparently, depending on whatever it is, but yeah.
Exactly. Yeah, for a Hello World application, I wouldn't be surprised if it's down to around that size.
Yeah. James, what were some of the other questions? I've just got to go scrolling back up the list.
May I ask a question?
Sure.
Yes. Mystery voice behind the faceless.
Yeah, like, why not take an advantage? Aaron, I've been tracking your progress with your voice conference application, and my question is, how much, is it feasible to implement it in Blazor at all? And especially if you need to deal with recording stuff, like those array buffers, streams of audio, you need to store them somehow. What would be the interop with JavaScript?
For anyone that's not familiar with the context of that, on my Twitch channel, over the last about month or so, I've been building a video conferencing application using a service called Azure Communication Services. I would not be going down the route of building that with a Blazor application because you would be finding too much overhead processing wise because it's doing a lot of stuff with WebRTC and it's going to need to be able to converting essentially those stream buffers back and forth between the things that are running raw in JavaScript and what's then available in .NET. So I think you would lose a lot of efficiencies by doing it that way. Admittedly, that's my expectation. I haven't actually tried it, but it's the kind of thing that I would probably not do in WebAssembly because I would see the translation back and forth, but for that kind of video processing is overly complex. And also for that specific use case, any sort of recording or video processing, I'd actually do on server. So have something that's sitting in between the clients, or sitting as an additional attached client that's monitoring the video streams as it's going through and actually recording that rather than trying to do it on a client's machine because it's going to be an intensive process.
Thanks. My thoughts exactly as it.
I got one last one. Yep. So for us lazy people who suck at doing CSS and go and grab various frameworks, a la Bootstrap Material or otherwise, has anything community-wise started turning up around those sort of libraries yet in Blazor land?
So there's one in particular that I'll call out. It's not in that one. There is a library. We have a look here. There's a group of libraries under a banner called Blazor. And this is doing a bunch of common things like you'd be interrupting with things like local storage, session storage, like common browser APIs. So check out the Blazor group of extensions. I have seen things for doing like the various CSS frameworks, so that they give you those like components that represent that sort of stuff. Yeah, so there's definitely things out there that give you that UI laziness that you could get out of using a CSS framework like Tailwind or Bootstrap or whatever it might be, but fit into the kind of component expectation. You don't have to go out and go, well, what's the 15 classes I need to put on this button to tell it the button is a button?
Yeah. All right, and James, do you want to bring up Lincoln's question there? Oh, look at that. Boom.
Okay, so there's a question. I don't guess I have to read the question because it's visible on stream. Well, actually, I'll read it for anyone that is vision impaired and can't read what's on stream. So the question is around app service supporting HTTP2, which means you can't host a gRPC server on that. Yes, that is currently still the case. As far as I'm aware, HTTP2 is not supported on app service. So if you want to run a gRPC server, you're going to need to run it in a container mode. So run it on something like Azure Container Instances or on an Azure, on AKS, the Azure Kubernetes Service. Container service. Yeah. I was like, do we call it Kubernetes or container service these days? I forget.
AKS is Kubernetes. Yeah.
Yeah. So if I was to be to host gRPC, I'd be doing that, or at a worst case scenario, going down and just rolling my own VM. Obviously, the reason I say worst case scenario for rolling my own VM is that means that I have a lot more infrastructure management overhead. But yeah, like that's kind of the final fallback that I would be going to. So yeah, first off, I'd start looking at Azure Container Instances, and can I run it with inside of Azure Container Instances? If that doesn't work, can I justify the complexity that we get out of AKS? So, you know, like having to manage Kubernetes and learn Kubernetes and write the reams of YAML that you're going to need for that. Otherwise, yeah, just a custom VM that you run the application within.
All right, we might pause the questions there.
Yeah, I say no doubt that there is definitely work being done to make HTTP2 supported on app service, because I constantly see it getting asked, and I'd be surprised if the team hasn't heard of it and isn't aware that people want that.
Yeah. All right, James.
All right, I turned yellow.
Thanks, Aaron.
Yes, thank you, Aaron. That was
thanks, Andrew, as well.
And I was going to finish just by saying. At the
risk of being unpopular, this reporter places the blame for all of this squarely on you, the viewers.
That's what you get for if you didn't enjoy tonight's session. Blame is squarely on you. And I think I've been uninvited from any future alt.nets.
Never.
For the rest of the year. So competitions. So I've turned yellow, but we can still do the competitions. I'm not quite sure why. Some sort of
you're going for your 70s sepia tone camera effect.
Yeah, not requested, but there you go. You can still hear me, right?
Yeah, we got you.
All right, that's good. So I've got two questions. So these are the ones that are like the questions that require you to have been thinking hard and listening and that sort of stuff, as opposed to the ones that will just require your fast typing next for the Microsoft things. All right, so first question, not very hard. It was mentioned quite a few times, but which library did Andrew recommend for canceling the JavaScript promises? There we go. Wow. Okay.
Bang, everyone's just gone smash.
Wow.
Someone even shouted it. Stephen, that doesn't work. Shouting doesn't get you in. It's actually Beepin' Ball Betty
is the winner. So
ding.
Ball Betty. It's the JetBrains license that is.
It is, Francis.
Sorry, Francis, you have to listen for the next one.
Amit, you got to type faster. Sarah, you too.
Oh, thank you, Aaron. Very good. Congratulations. And the next question. Now, this one should take a little bit more effort. So, what are
more than 4 keystrokes and an enter?
Yeah, that's right. The other one was too easy, as you can see. Everyone's getting ready for the Microsoft swag. Okay, so
someone's already typed in Blazor, ready to hit enter.
So the Blazor question is, what were 3 of the exciting new enhancements in .NET 5 for Blazor? Out of the 5, you need 3 out of the 5 that Aaron mentioned.
Oh, you're kidding me, Francis.
1, 2, 3. Wow. Well, I think, Francis, you are the clear winner there.
And well, we need to check the answer. Aaron, is that correct?
Yes.
JavaScript isolation, CSS isolation, and browser compatibility to TT analyzer.
Did you know what I was going to ask? Did you guess it? Oh, can't have too many JetSprains licenses. So hit me up afterwards. Send me a message on Meetup with your email address, and I'll send you through the license.
Yeah, absolutely. Like all good developers, cut and paste is the only way to work.
Well, maybe you found it on Stack Overflow. No, I'm sure he was listening well, and that's why he got it deservedly. So the other one, you happy for me to do the link, Richard?
Yeah, do it.
Yeah.
Okay, so just do we need to do a preamble and edge this out slowly?
I'm getting it in my clipboard. So we're lucky to. So I think it's a swag kit which has got a T-shirt and a mug, and thank you, Richard, and some stickers. What else has it got?
I think it's got a small bow and arrow, maybe a Leatherman.
We'll be in trouble.
James, maybe.
Picture of Richard.
Both of us hugging the .NET robot.
Yeah.
It's going to be floating up near Aaron's head, something like that. No, we actually don't know. It's an undisclosed bag of swag.
Yeah, but there's like multiple cool things inside. It should be at least as good as like hanging out at Microsoft stand at a conference, or better.
Yeah, absolutely.
Or hitting up several stands.
I didn't know that my daughter just walked into the room and stole my wallet and walked away again. So, parenting tips.
Yeah. Keep your wallet in a
Windows
safe.
3.1 installation floppies. That would be awesome. That would be great. Actually, so while we're talking rubbish, I remember installing the Office disks with floppies, 42 of them, stacked with rubber bands around every 10, so you didn't lose track of where you were up to.
And the worst case is when like 37 is corrupted, and then you're like, oh
no.
And you have to wait.
Or you had to jump back to number 8
to
put in another file.
Well, let me know when you're about to put the link up, because I've got the drum roll.
All right. We're just getting everyone ready. So now the thing is, right, so there's like about 15 or 20 of these kids. In the comments here. So anyway, there's about 15 of these. So the competition involved here, so it's not gambling, is that you have to go to the link and you need to answer very quickly and fill in your details, obviously correctly enough that you'll still get the swag. Otherwise, it'd be wasted if you mistyped it. So I'm the link. Is everyone ready? All right. 3, 2, 1. Here we go.
That was awesome.
Well done.
How well timed was that?
That was fantastic. that we saved the best like interactive part to the very end of the year.
Yeah.
Superb. 404.
You're just trying to throw off the competition, right?
No, okay, so here's the trick. You got to actually get rid of that promo bit where James has put it in.
You do need the code later, but not in the URL.
You've got to now actually do the copy-paste thing like all good developers that we were talking about before. So I'm assuming Francis has already done all that.
Francis has already got his swag.
No.
Me fail English?
Grab that.
That's impossible.
All right, that's awesome. All right, so go grab that code, grab your details, pop them in there.
someone has managed to successfully use it, right?
Yeah, I'm sure they can remove put the space in between the slash at the end and promo. I hope. Oh, great. And we've also got a spammer in there. Hello, spammer.
Yeah, and look, guys,
we should probably mute them.
It's competition for the link here. Don't click that one. Who knows? Can we? I don't think we can delete comments.
We can.
Okay. We've had a successful member get it. This is good.
Sweet.
All right, and it's a long time till nextalt.net. Good to see Lord Teaspoon. Yeah, so nextalt.net is in January. So if you've got something you want to talk about, you've got a long time to prepare, which means you can like give us a call talk.
We actually, the next one, again, ironically, this happens once every now and then. We've done this. We've been running the group long enough. We've managed to land again on Australia Day in January.
Oh, really?
Yep. So we'll work out which particular day of the week we're going to run it on. It won't be Australia Day because if you're doing the proper thing, you won't be in a fit state to make any sense of whatever we're talking about, and neither will our presenter.
Peace punch.
So we'll figure that out. We'll work it out. But it'll be sometime around the end of the month. Which would be awesome. And Aaron's killing a bug.
I've got a fly that keeps sitting on the light above my camera.
On that note, we finished the .NET and have a great Christmas, though it's still far away. And
enjoy your breaks. It's probably been a long year for everyone. Enjoy time with the family. It's good the borders are open around Australia now, so if you've got interstate relatives, hopefully you can catch up with them. We appreciate everyone jumping in over the year that's been with everything that's happened with COVID, and the fact that we've been able to make this group still run successfully with everyone remotely has been fantastic. For all our presenters, Aaron, Andrew, thanks again for tonight.
Thank you
very much for having me. Pleasure.
Keep spreading the word, share the group links. We love it, and we will catch you next time. Till then, as we say, bye.
Bye.